Imagine zipping across the galaxy faster than a blink, visiting distant star systems in mere moments. It is a thrilling thought, a staple of science fiction that captures our imagination with its promise of exploring the universe. But what if this incredible speed came with a peculiar side effect, one that could unravel the very fabric of time as we know it? Yes, according to our current understanding of physics, faster-than-light travel, often called FTL travel, would indeed cause time paradoxes. It is not just a theoretical oddity, but a direct consequence of Albert Einstein's theories of special and general relativity, which govern how space and time are intertwined. The core reason lies in the cosmic speed limit, the speed of light. Einstein's relativity tells us that nothing with mass can accelerate to or exceed this speed. As an object approaches the speed of light, its mass appears to increase infinitely, and the energy required to push it further also becomes infinite. More importantly, relativity reveals that time is not absolute. Different observers moving relative to each other will experience time differently, a concept known as time dilation. If you could travel faster than light, you would violate causality, which is the fundamental principle that an effect cannot precede its cause. This means you could potentially arrive at a destination before you even left, or send a signal into your own past, leading to paradoxes. To understand this, consider the concept of relative simultaneity. What is now for one observer might be in the past or future for another, depending on their relative motion. If an object could travel faster than light, it would be possible for that object to reach a destination and send a signal back that arrives before it even began its journey from the perspective of an observer. This creates a closed timelike curve, allowing information or even matter to interact with its own past. Such a scenario could enable a grandfather paradox, where one might prevent their own birth, or a simpler paradox like receiving a message before it was sent, making the sending of the message redundant or impossible. Physicists often refer to this problem as the tachyonic anti-telephone, named after hypothetical particles called tachyons that always travel faster than light. If such a device existed, you could use it to communicate with your own past. For example, you could send a message back in time to tell yourself not to send that very message. This logical contradiction is what makes FTL travel problematic for the consistency of the universe, suggesting it is either impossible or requires a radical rethinking of physics, perhaps involving concepts like wormholes or warp drives that manipulate spacetime itself rather than accelerating through it. So, while the dream of faster-than-light journeys remains a captivating vision for exploration, the hard science tells us it carries an intrinsic link to time travel and the profound logical inconsistencies of paradoxes. For now, the speed of light stands as the universe's ultimate traffic law, ensuring that cause always precedes effect and our timeline remains logically sound, preserving the consistent flow of reality.